I'm sharing screen now. Now see, are you able to see the semiconductor physics slide?
Yes, sir.
Fine, good. So now our electronic devices are fabricated using semiconductor materials. Okay, the semiconductor materials. We'll see certain basics which are necessary for us, because those basics they won't ask in exam. But without knowing those basics, it will be very difficult to analyze the subject. So for our convenience, I gave some basics. Actually, we are not going into too much depth on our semiconductor physics part, especially I'm going into certain levels only. We have to discuss. No need to discuss complete bonding levels. I will discuss whatever necessary parts and we'll proceed. Actually, this is only prerequisite. If you know this, it is better. But the thing is, it is not necessary to study these things for exam. Okay, these are the simple prerequisites. Actually, suppose if you want to study EMF, the prerequisites are basic vector calculus, like this. It is some of the basic prerequisites. Some basic semiconductor materials, I think you might have studied this in either plus 2 or in the first year level in just repeated sessions. Just listen carefully. So I will give this materials. Don't note it down. You try to maintain complete concentration on this mobile or laptop only, but don't take. I will give all the notes because I have a PDF. I have video lectures, everything. I will give it to you. Don't worry. Okay. So now semiconductor physics. First, we'll see. Before going to what is semiconductor, we'll see what are the materials. Actually, materials are classified into, I think you know, materials are classified into different types, three different types mainly. That is actually crystalline material. One is called crystalline material, other one is called amorphous material, third one is called actually pseudo crystalline. What is crystalline material? Crystalline material is nothing but actually, it is in crystalline material you have a crystal structure. In crystal structure, what do you mean by crystal structure? It has a regular arrangement of atoms or molecules. See here, if you observe this diagram, here you will find crystal structure. All are in a regular arrangement. If you see, you won't find any mismatch like this. A perfectly regular arrangement. Here also regular arrangement. Here also regular arrangement. It is also crystalline structure. It is also crystalline structure. Crystalline structure. So these are the perfect regular arrangements of atoms or molecules. We have to study mainly about atoms only, but not all things. But before going to these atoms, all these semiconductors, the basic fundamentals behind these atoms we will discuss. So the regular arrangement of atoms, we are mainly discussing with not liquids and gases. We are discussing only with solids. So regular arrangement of atoms or molecules, that too repetitive manner. See, whatever may be the manner, it is going to be repeated here. It is called crystalline structure. Next structure is going to be amorphous. What is amorphous? It is exactly opposite to crystalline. Okay. So obviously there is no proper arrangement. You see here, there is no proper arrangement. There is a gap here. You will find, if you will find gap, there is a gap here. There is a gap. But if you see here, don't think this is a gap. Actually, they are arrangement properly. So it is going to be a completely random arrangement. Random arrangement. Third one is going to be pseudo crystalline. What is pseudo crystalline? Actually, arrangement is here somewhere. Everywhere arrangement is there. Whether it is crystalline, amorphous, or pseudo crystalline, arrangement is there. The arrangement is between crystalline and amorphous here. Arrangements are bit, and it has arrangement, but only over shorter distances. I think you know the main thing regarding this pseudo crystalline is going to be a lattice cell. I think you might study lattice. Yes, clear. You know lattice cell. Sorry, I'm a unit cell. You know unit cell. It is lattice crystal structure. It will be very useful. FCC, BCC. You know unit cell. Someone tell me, you know unit cell. You might study in physics. Unit cell. Someone respond whether you know unit cell or not. What is unit cell? Someone tell me. Someone from your class. What is unit cell? You forgot everything. What is unit cell?
Smallest group of atoms.
Yes, smallest one. Actually, it is in a periodic manner. Yes or no? Smallest thing. It is a periodic manner. So this that is going to be that unit cell. The term is very popular because that is useful in semiconductor materials or any electrical engineering materials. And the subject is not there for us actually. That is electrical engineering materials. You might study that actually. That unit cells are very useful for FCC, body centered cubic, BCC, face centered cubic, FCC. Those are the basic physics which we don't want to discuss. But these are materials, general materials. But for us, what we need to discuss is materials classification based on conductivity. Okay, classification is based on conductivity. Why? Because we have to bother about semiconductors. There are three materials are there. One is called conductors, other one is called semiconductors, third one is called insulators. Okay, so how these materials are classified into different categories? The main thing is these materials are classified into different categories based on conductivity. Actually, conductivity. What is conductivity? We'll see that. Actually, what is conductivity? In general, if you observe conductivity means, so suppose we'll discuss what is conductivity. First, you take resistance. What do you know? The resistance are equal to rho L by A. So what is the rho? Rho is called your resistivity. L is called the length of material. A is called area of the material. So that is called resistivity, rho L by A. So what is R? R equal to resistance. Rho is resistivity. 1 by rho. It is called 1 by rho is called sigma, which is called our conductivity. And sigma. So sigma is called conductivity. Conductivity is nothing but current carrying capability. That sigma is proportional to N. So what is N? I will tell. See, what is N? Concentration of charge carriers. That is number of charge carriers. Just 1 second only. I need to fill one small feedback form. Just 1 second. Just 2 minutes. I feel feedback. Okay. Thank you. Thank you for your cooperation. Sorry, Andy, small disturbance. Where we are, see here, we are at the conductivity level. So conductivity, it is called sigma. Sigma is called conductivity. Conductivity is proportional to N. What is N actually? Concentration of charge carriers. Concentration of charge carriers. So that is nothing but it is number of charge carriers. That is called concentration. Concentration. That's called number of charge carriers. So by Ohm's law, someone tell me what you know Ohm's law. Someone tell me what is Ohm's law? What is Ohm's law? Please respond.
Equal to IR.
Array V equal to IR is Ohm's law. That is correct.
At constant temperature and pressure,
Yes.
shall
Constant mainly at constant temperature అండి. Yes, clear? Array Sayaditya K. You should not say V equal to IR. If you say V equal to IR, people used to say that is absolutely wrong. Someone tell me, anybody from your section is there? Sunny Saket?
Yes, sir. Yes, sir.
Okay. Okay. What is the definition of how you have to describe Ohm's law? First, you should say, before saying V equal to I or whatever maybe, at constant temperature. At constant temperature. Why? Because you know the resistance R equal to RT into 1 plus alpha into delta T. That is the resistance always changes when temperature changes. So at constant temperature, you can say the standard definitions. Actually, it is actually what we are going to study, the Ohm's law, which is derived from field theory, and that is called this one. Actually, if you see field theory form, it is called field theory, electric field. See, if you observe J, what is J? J is called current density. Current density. J is called current density. It means current per unit area. Current density means current per unit area. Sigma is conductivity. E is nothing but electric field, that is called voltage at given length. So LL area meters. Here it is units meters. Area both gets cancelled. So I equal to, what is rho? R equal to rho L by A. Sorry, and this is actually. So what happens actually? So I equal to sigma into V. So what is Ohm's law? V equal to R is proportional to rho. So obviously V equal to I by sigma. It's called V equal to I into 1. This is called Ohm's law. Whatever may be the Ohm's law, this is actually derived from this. Actually, in field theory form, you are going to study this. Poonam madam will explain this. They will derive. In field theory form, this is going to be Ohm's law, and in circuit theory form, V equal to IR is the Ohm's law for us. Okay, we derived from this by Ohm's law in semiconductor materials point of view. See, so J equal to what is J? You can ask, J is current density, and current density, that is called current per unit area. Unit is called ampere per meter square. So that is depends. Okay, current density. Next, sigma is conductivity. E is called voltage that is given like ampere per meter. So what happens actually if you see, if sigma is proportional to n, what is sigma? Sigma is called our conductivity. So conductivity is proportional to n. N is nothing but number of charge carriers. Now what happens if more number of if you take any material, that material has more number of if you take any material, that material has more number of charge carriers. Obviously, your conductivity is more. If conductivity is more, so sigma is J is proportional to sigma. If sigma is more, obviously current density is more. Current density is more. If J is more, obviously what is I told? J equal to I by A. So if J is proportional to I, if sigma increases, current density increases. Current density increases, current increases. That is the relation. Conductivity increases proportional to current increases. This is the relation. Okay, field semiconductor relation. So if sigma increases, this is the sequence, and if sigma increases, current density increases. This is called J, and current increases. So if material has more number of carriers, means conductivity increases, current increases. More number of carriers means more number of electrons are contributed to higher current. So more number of carriers means by default more number of electrons. Okay, concentration. What do you mean by I told from the beginning onwards sigma is proportional to n? What is n? Concentration. What is n? Concentration of charge carriers. What do you mean by concentration? Concentration is nothing but number of charge carriers per a unit volume. Actually, number of charge carriers per a given unit volume. How many number of charge carriers are there? Actually, based on this number of charge carriers per unit volume, based on this concentration only, and based on this concentration only, our materials are classified into conductors, semiconductors, as well as insulators. So, what is the unit concentration? Number of charge carriers per unit centimeter. It's called cube. That is the unit. So, based on this only, we have to study the material classification. Okay, the basic difference between above three materials. Above three materials means what are those three materials? Conductors, semiconductors, and insulators. These three materials is mainly depends upon the number of charge carriers concentration. Okay, if you take insulators, what happens in an insulator? The maximum concentration per centimeter cube per unit volume is going to be 10 power 6. 10 power 6 is the our charge carrier concentration. Yes, clear? It is a maximum concentration. If you take semiconductor, it is going to be more. Actually, it is going to be more when compared to insulator. Is the conductivity of insulator is going to be very, very poor, that So semiconductor, in semiconductor, the maximum concentration is going to be 10 power 21 per centimeter cube. It is the maximum concentration, and anything which is above 10 power 21 per centimeter cube, any concentration which is below this, actually below this level, we are not considering a semiconductor. It is in the level of insulator and about to conduct, and above anything above 10 power 21 per centimeter cube, the maximum concentration above this is going to be a pure conductor. So what happens actually if in a given volume, if you have more than 10 power 21 carrier concentration, more than means more number of electrons. Actually, these electrons are very rich in that material. So those materials are called as actually conductors. It's clear, those materials are called as, we used to call as conductors. Okay, what happens actually in semiconductor? What happens when in semiconductors, the special properties, the special advantages, you can vary n. You can vary it. N is nothing but a charge concentration. You can vary. N is going to be varied, and sigma is variable. Why? Because sigma is proportional to n. You know how n is going to be varied in future. Why? Because in semiconductor, what happens if you increase the temperature? Earlier, I think I will show the energy band diagram. 1 second for our glimpse, and then we'll go to another part. Yes. If you see, listen everyone, in a semiconductor, it is called EC. It is called what actually? It is called your conduction band, and it is called your valency band. If you see, listen, tell me. I think you might study in +2 or even in first year. There is certain gap called EG. What is EG? What is EG? What gap? It is actually forbidden gap. Okay. So you need to apply certain amount of energy. So that what happens actually, carriers are able to move from valency band to conduction band. Okay. So if you're not giving a T equals 0 degree Kelvin, or if you're not applying any temperature, what happens? No carrier is able to jump from from valency band to conduction band. So if temperature is zero, is nothing but obviously conductor is acting as an insulator. Okay, that is a base. That is a property which you are going to observe. So this will discuss actually in semiconductor part. In semiconductors, when unvaried, how it is going to vary by extra energy, either temperature increases or impact ionization. These are the procedures. When temperature increases, obviously number of carriers are getting more energy, then obviously you have more number of carriers, your sigma conductivity is going to be a variable parameter. So when temperature varies and is going to vary, range of concentration is going to be large in semiconductors. That's clear. So next thing is going to be band diagram. Before going to any band diagram, I will explain clearly what is atom. All these things we'll see now clearly. If you have any doubts, you can ask me now during chat box or at the end of class, or you can ask any doubts. Now come to semiconductor physics. If you go to semiconductor physics, see what happens actually. The basics go. Okay. So now see here, I told in the structure, listen everyone, I told in the structure, uh, crystalline structure, amorphous structure, or pseudo crystalline structure. Actually, there is a proper arrangement. Periodic arrangements are there. There are proper arrangements of atoms and molecules. So we are only bothering about the atoms only. So what is atom? Atom. So you see now atoms. We'll see what is atoms. Atoms are made up of three types of particles called protons, neutrons, and electrons. If you see here, suppose if you take any carbon atom or any silicon or germanium, anything, if you take suppose if I take any silicon actually, okay, it is called it is called it is called nucleus. If you see, it is called nucleus. What he said actually, atoms are made up of three types of particles called protons, neutrons, and electrons. Okay, so here you have a protons. Okay, here you have protons and you have neutrons. Okay, it is called your nucleus. Here you have protons and you have neutrons. This is called silicon. It is called energy levels, and energy levels are orbitals are we used to call as shells. Okay, so inside it is nucleus. Nucleus. Here you have a protons. Here you have neutrons, and here you have electrons. That's clear. So I think you know, atom has a central nucleus with the protons and neutrons. That is nothing but actually it is called central nucleus. It is called central nucleus. CN, central nucleus. Central nucleus with the protons and neutrons, which is nothing but you have a protons, you have a neutrons. So protons are positively charged. Yes, protons are positively charged. Neutrons, no charge. Charge is going to be zero. So obviously, what is the nature of nucleus? Nucleus is positively charged or negatively charged? Tell me, nucleus is positively charged or negatively charged? Nucleus is positively charged or negatively charged? You have to respond.
Positive.
Why?
Nucleus contains protons and neutrons, sir.
Okay, then
Positive charge.
why? Actually, why? Because See, there is neutrons zero charge. There is no charge. So only charge which is exhibited inside the nucleus is what charge? Positive charge. So our nucleus is going to be what charge? Nucleus is positively charged. That is the reason. Okay, nucleus is positively charged. So whatever may be orbitals or shells or which are revolving around the nucleus. So those each and every shell should have electrons. That is depends upon their atomic number. So those electrons are actually negatively charged. Yes, clear. Listen, I will tell one thing. I will tell one thing. This COVID pandemic situation. See, by luckily, by God's grace, we all got actually negative. We didn't test. We didn't go for test. We assume that we are healthy, so we are negative. Why we are negative? Why electron is negative? It's clear. Someone tell me why. See, you consider our nucleus is COVID. It's clear. You consider our close friend COVID-19. So we are always maintaining distance. So it's me or you or someone. So it is nucleus. People who are near to this actually they got positive. We are far away from this. We are maintaining social distance. So actually what we got? We got negative. That's clear everyone. Ardhamainda? Are you able to understood what is our how our nucleus is related to us? Is clear?
Yes, sir.
So we are past two, so we are so happy. The reason is we are maintaining social distance. We have to maintain social distance up to some time. Okay. So electron is always negative. You remember why? Because it is maintaining distance with nucleus. So we not only me, we all together as a negative. So protons and neutrons are collected. See here we protons. Here protons are there, neutrons are there. Protons and neutrons. Protons and neutrons. Protons and neutrons are collectively called nucleons. We used to call together the what is there in the nucleus means actually nucleons. Nucleons is nothing but protons and neutrons are called nucleons. Electrons are negatively charged. I think you know and are located around the nucleus. Yes, clear. If you take it is a nucleus, electrons are revolved actually in the orbits, shells. We used to call orbits or shells. So it is going to be around it is nucleus means it is going to be revolve around this like our solar system. Okay, around the nucleus, an atom has isn't everyone. This point is very very important. An atom has same number of negatively charged electrons and it has positively charged protons in the nucleus, which is nothing but atoms are electrically neutral. We used to say why atoms are electrically neutral. Suppose, see, if you observe atoms are electrically neutral means suppose if you take it is called your nucleus, it is having positive protons. Here electrons are there around the nucleus. So what happens? An atom has same number of positively charged electrons. Suppose if you have 10 electrons, obviously, and it has positively charged protons in the nucleus. It has 10 protons. Obviously, what happens? Atoms are electrically neutral. Atom is electrically neutral. Why? Because 10 electrons you get. Suppose 3 electrons you get. Certain 4 protons you will get access. So obviously, positive charge, negative charge. Obviously, you know the net charge is 0. So that's why atoms are electrically neutral. It's clear. So electrons are negatively charged. Nucleus is positively charged. Okay, protons are positively charged, neutrons are negatively charged, atom is electrically neutral. This is the basic condition. So this actually it is one atom. What we are going to see is one atom, and we should analyze the behavior of one atom. Once we analyze the behavior of one atom, we will apply this same concept to the n number of atoms. Why? Because if you take semiconductor is very rich in, I told, number of charge carriers. So many atoms in a solid, atoms are bonded together or close together. We have more number of atoms. So if you take one atom or two atoms, obviously what happens? Two atoms are sharing their neighboring electrons and it produces certain amount of forces and form together, forming a bond called covalent bonds. We'll see that actually. First we will discuss one atom, then we will see how one atom is going to be attracted with other atom. What are the forces are available? If forces are available, what happens? What is the change in the energy levels? If there is a change in energy levels, how it is reflected in the energy band diagram. And we, you know, a valence band, conduction band, So how valency band is formed, how conduction band is formed, we'll see that. Okay. So electrons are distributed. Now electrons are distributed in a definite path around the nucleus and are called shells and orbits. Actually, it is actually modern physics, and this is actually related to modern physics. According to Niels Bohr, different electrons revolve around the nucleus in their different orbits. Actually, earlier the concept is actually electron revolves in the path and it gets actually uh, accumulated in nucleus. That is different actually. So according to Bohr, Niels Bohr concept, this is related to modern physics concept. Different electrons revolve around the nucleus and they and in their own different orbits, which is nothing but actually suppose it is called our nucleus. Suppose if you take carbon atomic number is 6. So 1s2, 2s2, 2p2. What happens actually if you consider this as the first shell, this is called valence shell. Obviously, what happens actually here 2 electrons are there, here 4 electrons. So obviously, what happens actually if you take carbon, according to Bohr model, are different electrons. Different electrons revolve around the nucleus in their own different orbits. Means these 2 electrons are revolving in these 2 orbits. It does not actually, without giving any energy, these 2 electrons does not come to this orbit. Suppose these 4 electrons are revolving in this orbit. If you apply any energy, already actually these two electrons are revolving in this orbit. So whatever may be the energy associated with this orbit, so those energy as possessed by these electrons. So when you apply external energy, there may be a chance this electron will be moved from here to here. That's clear. Why? Because same energy is applied to this external valency shell also. So electron is coming out from the valency bond. So this is going to happen. So without giving any energy, electrons are revolving around this nucleus. So atom is compared with solar system, nucleus is our sun. Okay, electrons is called our planets. So just like planets, this is general example. This is general example for your understanding. There is no, just like planets in the solar system, each electron revolves around the nucleus in its own different orbit. Actually, in its own orbit means actually every electron is revolving in one different orbit, in its own different orbit. The orbits are shells. Are represented by letters. I think you know KLMN. This is what, and the formula is going to be 2n square. That is already but I am saying for just for the recall. The maximum number of electrons present in a shell is given by formula 2n square, where n is the orbit number of energy levels. K shell, L shell, M shell. If you go for K shell, so K shell is going to be first shell, n is going to be 1 for K shell, and it is going to be n equal to 2, n equal to 3 for M shell. So the maximum number of K shell is going to be 2. So maximum number of electrons is going to be 8. M shell, it is going to be 18. Now you see the electrons present in the outermost shell. It's clear. Suppose you take carbon. It is called atomic number is going to be 6, and it is called the valence shell. It is going to be outermost shell. If you take 1s2, so it is 1s2. It is 2s2. So here you have 4 electrons. It is outermost shell. If you take silicon, atomic number is going to be 14. So based on the atomic number, their outermost shells or valence shell is going to be very okay. It's clear. So based on the atomic number, so the electrons present in the outermost shell, that's called valence shell. We used to call outermost shell is also known as valence shell. It is very, very important. Why? Because electrons are actually they share another neighboring neighboring atoms. Atoms are sharing their electrons, valence electrons, with the other atom. So together a bonding, that is called valency bond. For the valency bond, conduction bond only. Those actually share one atom shares outermost electron with other atom and form a bond. Those bonds are called covalent bonds, and those are in the valency bands. Basically, a bond is called covalent bond, and the band is called covalent bond. I think you know this in study in the physics. So outermost shell of an atom are called valency electrons. So valency electrons, and the shell which valency electrons occupy is called valence shell. Valence shell molecule. Next valence shell. If 2 or more atoms, that's clear. So what is molecule? If you ask, if 2 or This is for our understanding. Why? Because we studied molecules and atoms are arranged in regular manner. If two or more atoms are chemically bonded together, then it is known as a molecule. That's clear. Then it is known as a molecule. Atoms combine chemically. Oh, sorry. Atoms combine chemically by external factors such as heat and light. I think you know these are the external energy sources: heat, light, impact, ionization, bombarding, all these things, external energy levels. So heat and light, this leads to formation of a molecules. This leads to formation of a molecules. During the formation, atoms lose valency electrons and gain valency electrons from other atoms. So actually, two or more atoms combine is called molecules. So when atoms combine chemically by external factors such as heat and this leads to formation of molecules. During the formation of this molecules, atoms lose valency electrons and gains valency electrons from other atoms. We will discuss actually what is the meaning of losing electron, gaining electron. That is called actual ionization. We'll see the ionization. Now silicon atom. See, you know, this is what. So why we need to discuss silicon is the most popular semiconductor materials. If you know the most popular semiconductor materials, silicon, germanium, it is it is gallium arsenide. Okay, gallium arsenide is the these three are the most popular semiconductor materials. Nowadays, these are using in VLSI and chips, VLSIC, very large scale integrated technology, integrated circuits, chips. We used to study microchips. We used to study in the next semester regarding ICs. So they are using these materials. Okay, silicon atom. So we'll see the basics of silicon atom. Till now, what we study atom. So what is atom? Atom is nothing but it consisting of protons, it consisting of neutrons, it consisting of electrons. In the nucleus, we have protons and neutrons. So we can call nucleons. Proton is positively charged, so neutron is no charge. So obviously our nucleus is positively charged, and atoms are electrically neutral. Number of positive protons is equal to number of electrons. So silicon. So we study the basics of atom. Now we'll see silicon atom. Why? Because silicon is a semiconductor material. We are studying about the silicon atom. Silicon atomic number is going to be 14. So 14 means actually silicon atom contains 14 electrons. That you know we already studied. Carbon is 6 means outermost carbon. We studied carbon atomic number is 6. 6 means 6 electrons. 2 at the inner shells, 4 at the outer shells. So he similarly 14 means silicon atom contains 14 electrons. 14 means 14 electrons. 2 in the first shell. That is depends upon this one. Actually, this configuration. 2 in the first shell, 8 in the shell, 4 in the outer shell. You see, this is called 2 8. Hello? Someone just tell me. Any doubts? You want me to explain anything? Can I continue? Someone say, can I continue? Varma, any doubts?
No, sir.
You want me to continue? Okay, Amma. Now see, you see, K shell maximum electrons are 2. Here maximum are 8. Here maximum are 18. So if you go to silicon, it's clear. So if you go to silicon, the maximum is going to be first shell 2, and second shell is going to be 8. Third shell is going to be 8 in maximum, but we have 4 in the valence shell, outermost shell. So silicon, so 1s2, 2s2, 2p6, 3s2, 3p2. So it's nothing but actually, so first, that's called the first level, which is very much near to nucleus, having 2 electrons. Next level, so having 8 electrons, and outermost shell having 14 electrons. So 2 plus 8 plus 4 is going to be 14 electrons. That is the, so if you see silicon atomic structure, if you observe clearly, so outermost orbit contains 4 valence electrons. If you see 1s2, so it is called 1s2, you have 2 electrons, and next you have, how many electrons? You have 8 electrons. You see, this is called 8 electrons. So it is called nucleus, and here you have a protons and a neutrons. This is the, so it is nucleus, and it is called inner shell. K shell 2n square, 2 into 1. The maximum electrons are 2 electrons. I think we studied. And this one is called next shell, L shell. second shell 2n square. So 2 into 2, the n is going to be 2 here. N is nothing but energy level, shell, second shell. So n is going to be 2. 2 into 2 whole square is going to be total 8 electrons. And it is, see here, third shell. The maximum number is 18 electrons, but we have 4. So it is 1 electron. It is 1 electron. It is 1 electron. It is, so 4 electrons at the outermost orbit. So silicon atomic structure. If you see silicon and germanium, both actually you will find outermost orbit 4 valence electrons. Germanium atomic number is going to be 32. So these 4 valence electrons actually under, if you take single atom only, actually this nucleus is this all valence electrons or all electrons are in the shells. They are revolving in their own orbits. They are not coming out until unless if you're not providing any external energy. If you're providing any energy, will obviously electrons are coming out from their shells. It's clear. So vicinity of the nucleus, every electron is there. Okay. Then energy band diagram. See, that's what I told. And what is energy band diagram? See, energy band diagram. What is energy band diagram? We'll discuss. Band. Every time we used to say energy band, energy band. What is band? Band is nothing but actually group of energies. And band is nothing but what is band? Band is nothing but group of energies. Group of energies. Band, you remember this? Band is nothing but group of energies. Till now we studied energy level. That is energy level of single atom. When you combine in a solid, atoms are closed together. So in a solid, so many number of atoms. Each atom has one energy level. If you combine n number of atoms, each atom have one energy level. So n atoms, n energy levels. All energy levels are combined together. This combined energy levels is called as band. That band is called group of energies. So it consists of valency band, energy band diagram. This is energy band diagram mainly consists of valency band, you have conduction band and forbidden band. Okay, I will tell what is valency band, actually what is conduction band, and I will tell. It's clear. Based on the energy band diagram, materials are divided into conductors, semiconductors, and insulators. That's what we discussed. Concentration. Based on the concentration, carrier concentration only we used to discuss. So you see silicon atomic structure. So according to modern physics, so only discrete values. According to modern physics, only discrete actual discrete meaning is different. And different values of electron energies are possible. It means that each isolated atom can have only certain number of orbits. So it is certain number of orbits. It's just a little bit theory. Okay. These available orbits are shells. Shells present. So shells represent energy levels for the electrons. Electrons can revolve only in the permitted orbits, do not and not in any intermediate orbit. Okay, it can only permit to revolve in that particular orbit. Each orbit has fixed amount of energy. See this one. Each orbit has fixed amount of energy associated with it. Means suppose first orbit is having some fixed amount of energy, second orbit having some fixed amount of energy, valence shell have some fixed amount of energy. Each orbit has fixed amount of energy associated with it, and electrons moving in a particular orbit possess the energy of that orbit. So suppose if electrons are revolving in the first orbit, means whatever may be energy of orbit, same energy is attained by those electrons revolving in the first orbit. If it is second, means obviously same will be applicable for second as well as valency. The larger orbit, greater its energy. Suppose valency shell have more energy when compared to shells which are very much near to nucleus. Hence an electron in the outermost orbit have more energy than inner orbits. That's clear. So suppose, so it is called electron energy E. It is called structure, and if you take, it is called silicon atomic structure. If you take energy band diagram of this one, we'll take. I didn't mention valency band, conduction band. Simply I'm taking. So it is, if you take silicon, it is called actually our nucleus. So that is called edge of nucleus. So it is first orbit. It is called second orbit. It is called third orbit. So it is called first, second, third orbit. So n equal to, it is whatever may be energy levels associated with first orbit, energy levels are associated with second orbit, energy levels are associated with the third orbit. That's called valence shell. See, some books will be represented like this: n equal to 1, 2, 3. Clear? So similarly, that is called silicon. Now we'll see germanium. What is germanium? It is another semiconductor material. It is another semiconductor material. So germanium atomic number is going to be 32. So here 1s2, 2s2, 2p6, 3s2, 3p6, 310, 4s2, 4p2. Maximum energy levels. Maximum energy level is going to be 80. Here 18 is fulfilled. Previous case, only 3 shells. The silicon, the maximum is going to be, we'll get outermost shell 4 electrons. Here also outermost shell 4 electrons actually. 4 electrons, semiconductor materials. Now you see, so nucleus we know, no need to discuss, we already know. So valence shell. So valence shell, we have valence electrons. For our understanding, I draw this. When there are 4 electrons, that's called valence electrons, in the outermost orbit, the semiconductor material referred as pure or intrinsic semiconductor. We'll see next class classification of semiconductor pure. That's called semiconductors are classified into 2 types, pure and impure. Why we used to call impure semiconductor is actually when if you are not adding any external impurity, that is called pure semiconductor. The drawback is conductivity is low. So to improve the conductivity, you have to add external impurities. So those external impurities will change the concentration. Those impurities either actually those that the adding of external impurities, the process is called as doping. That is called either you can add pentavalent impurities or trivalent impurities to make normal semiconductor into either p-type semiconductor or n-type semiconductor. Trivalent impurities, pentavalent impurities, like all impurities. We are adding PAP and BAG. You know the word: phosphorus, boron, antimony, arsenic, bismuth, indium, gallium. These are the materials we used to add. Some of them are trivalent, some of them are pentavalent. Pentavalent is nothing but actually 5 electrons in the outermost orbit. Another one is going to be 3 electrons. So if you have 3 electrons, you will find one hole. If you have 5 electrons, that's called pentavalent. You will get 1 electron additional. That we'll see the coming sessions. Each silicon and germanium has 4 electrons. I think you know you see the atomic structure in previous slide, has 4 electrons in its outermost orbit. Okay. Now next, see the amount of energy required to extract the valence electrons from the outer shell is very less. Why? Because actually already it has certain amount of higher energy. Suppose if you apply any energy, what happens actually? The electrons which are available in first shell, they move to next shell. Then if electrons are there in the outermost orbit, outermost shell, actually they are loosely bounded to the nucleus. If electrons are very much near to the nucleus, these are tightly bound. If it's the outermost orbit, those are actually loosely bounded. If loosely bounded, what happens if you apply external energy? Easily electrons are able to jump from valency band to conduction band. Okay. So outermost shell, each shell has a fixed energy level associated with it closer to the shell. Closer the shell to the nucleus. As I told, no, suppose if it is first shell which is very much closer to the nucleus, more tightly bound to the nucleus and possess lower energy level. Next, energy level of shell 1 is the lowermost and energy level of valence shell is highest. That's why I told, no, energy levels of valence shell is highest. Why? Because this is not that much tightly bound to nucleus, it is loosely bound to nucleus. Tightly bound, if it is going to valence, it is going to be loosely bound. It is loosely bound. So higher energy level indicates indicates that higher energy level indicates that the electrons of that shell are loosely bound. Yes, I told, no, this is called loosely bound to the nucleus. Hence, valence electrons are loosely bound to the nucleus. That's called valence electrons. See here. So it is called nucleus. Shell 1, shell 2, shell 3, valence electrons. Yes, is called shell. Energy level increases from shell 1 to valence shell as the distance from the nucleus increases. Yes, if you observe germanium, if we are taking for silicon, if you take germanium, we have another shell 4. So shell 1 is tightly bounded, less tight compared to S1, loosely bounded. S4 is completely loosely bounded. So if you apply energy Obviously, electrons are able to jump from outermost shell or valence shell to conduction band. So when atom, this is basics, just some theory part. Once we finish this theory, full of circuits only, don't get disappointed with this theory. When an atom absorbs energy from heat source, actually I told how electron is able to jump. How till now what we discussed, valence electrons are there at the outermost orbit. What we used to say, how what we say, these valence electrons are loosely bound to the nucleus. If they can easily jump from valency band to the conduction band, how it happens actually when an atom absorbs energy, or if atom is subjected to any external energy. Atom absorbs energy from a heat source. I told you heat or light from light source are due to high atmospheric temperature and impact ionization bombarding those processes. The energy levels of electrons are raised. Why? Because already certain energy levels are there. You are giving energy externally to any atom. So obviously the energy levels of the electrons are raised. So when you're providing external energy, energy levels are raised. When such additional energy is imparted, means you are giving external energy. When such additional energy is imparted, means giving to the electrons. The electrons move to the next orbit, means from first orbit to second orbit to third to fourth, whatever maybe depends upon atomic number, which is far away from the nucleus. So obviously they are able to move from first orbit, earlier first orbit, so tightly bounded, very much near to the nucleus. You are giving external energy. What happens actually? Electrons are able to jump from first orbit to second orbit. Then obviously what happens? Far away from the nucleus. So bonding also somewhat loosely bounded. Energy increases loosely bounded. So bond is inversely proportional to the energy levels. But as a valence electron, it is in the outermost orbit. Actually it gets completely removed from the force of attraction of nucleus. Earlier, valency electron is in the vicinity of nucleus with high energy, with loosely bound. But if you are applying external energy, what happens? That energy will acquire some additional energy to the valence electron. So obviously what happens? It is loosely bounded. It is easily able to jump from the vicinity of the nucleus. So obviously from now onwards, once valence electron is completely removed from the force of attraction of nucleus, so we cannot call that electron as valence electron. What we can call that electron? Someone tell me what is the name of that electron? What is the name of that electron?
Excited electron.
Excited electron. Also known as what electron? Free electron. Is clear? Those electrons are also known as free electrons. So that is valence electrons moves away from the vicinity of nucleus. An electron which is not subjected, an electron which is not subjected to the force of attraction of the nucleus is called as free electron. That's called excited electron. Such free electrons are responsible to the flow of current. If till now electron is in the vicinity of nucleus, it is in valency shell, it is in valency band, and it is also in covalent bond. So the moment if you apply external energy, electron is able to jump from valency band to another band. What is the name of another band? Those in that band, completely free electrons available. What is the name of that band?
Conduction band.
Very good. That is conduction band. I will tell how conduction band is formed, how valency band is formed once we finish this discussion. Okay, free electrons, flow of current. Okay, this point is very useful point. More number of free electrons, better the conductivity. I told no, more number of free electrons, that is nothing but more amount of charge carriers. It is proportional to conductivity and is proportional to sigma of the metal. Metal is nothing but dependent conductors, semiconductors in general. So ionization, and I will tell the word called ionization. Why ionization is very, very important. You will understood after some time. This is ionization. Ionization. What is the process of ionization? What do you mean by ionization? Listen, if an electron is extracted from outermost shell, that means we are applying energy either through heat or light or impact ionization or any other process. If an electron is extracted from outermost shell of an atom, then overall negative charge, listen carefully, then overall negative charge of that atom is decreases. Why? Because we are extracting an electron. Overall, in an average base, atom is electrically neutral, but what happens in the process? If an electron is extracted from outermost shell of an atom, means one electron is coming out from the valence shell. If there is no electron, some space is left free. That is called hole. Okay, the overall negative charge of an atom decreases as it loses negative charge in the form of an electron. As clear, negative charge decreases ఎందుకంటే as it loses negative charge in the form of electron. But the number of proton remains the same. You listen carefully. This is the word, very very important. But number of protons remains same. Hence positive charge remains the same. This is very, hence positive charge remains same. So remains the same. So atom as a whole loses its electrical neutral nature and becomes positively charged. Why? Because positively charged. Earlier we discussed atom is electrically neutral in nature. But what happens if you apply any energy? What happens within that small instant? It loses its outermost electron. If you lose its outermost electron within the smallest time, obviously negative charge it loses. So positive protons are remains the same. So it becomes positively charged. Why? Because protons are more when compared to that valence. Why? Because we lost the valence electron. Such an atom is called as a positive ion. Such an atom is called as positive ion. Such an atom is called as positive ion. Next. Similarly, if electrically neutral atom gains an additional electron is nothing but obviously negative charge. Then it becomes a negatively charged, then it becomes negative charge, and it is called a positive negative ion. Thus, see here, thus by losing or by gaining, either losing electron or gaining electrons, an atom gets converted into a charged, either it should be positive charge, negative charge depends upon either it is gaining electron or it is losing electron. This process of gaining or losing an electron, that's clear, which converts, listen, thus by losing or gaining electrons, an atom gets converted into charged ion, either it should be positive charged ion or negative charged ion. This process of gaining or losing electron, which converts electrically neutral atom. Earlier, atom is electrically neutral atom, but the atom is converted into ion, into a charged ion. This process is known as ionization. What is ionization? Ionization is a process of gaining electron, losing electron, converts electrical neutral atom into a charged ion. This is known as ionization. So ionization. Now we'll see, this is the basics of atoms and semiconductor materials basics, and energy band theory. What is energy band theory? I told band is nothing but group of energies. Energy band theory means all the energies associated with the semiconductors. We'll see here energy band theory. The largely here from now onward we need to discuss about completely. Sorry. Energy band theory. So valency band, conduction band. This before going to study this energy band theory, we'll see what is energy band theory. We'll discuss now. We'll shift to another slide. Here, band diagram. Band diagram. You want me to stop or you want me to continue? 1 hour is over. Maximum 1 hour you can take. You can't take beyond that. Can I continue or you want me to stop? Someone tell me. No problem. It is online classes on interactive classes. Someone should respond. If you want, I'll continue. Else I'll stop. No issues, and we'll discuss. We have enough number of classes. Don't think that actually if we say that sir please stop class, sir will get angry. This is not that kind of thing. Since it is online now. So we have to take care of your problems. Tell me if you want to continue.
Stop, sir. Lunch break.
Okay, good. We'll go for lunch break. Thank you. I'll stop. Okay. So attendance, Varma,
Sir,
attendance possible అవుతుందా?
attendance. I took a screenshot, sir.
Okay, you just send those screenshots to me. Okay.
Okay, sir. I'll send to you.
Okay. Okay, Amma. Yeah. Okay. I'll stop today's class, and if you have any doubts, I will wait. If you don't have doubts, you may leave now. No problem. No issues. Any doubts, you can stay and ask. Else you may leave. No problem. I'll stop recording.